We should be recording now. Yes, and I will post this in Google Classroom. So if you guys missed something here in this little tutorial, rewatch it. I'm going to stop recording probably after like 5 or 6 minutes, just so the video doesn't become too long. So what we're going to do first thing is we need to find the element on the periodic table. So let's go ahead and find an element, and we're going to, for our first one, let's go ahead and do carbon. All right, so I'm going to draw the square here. And if you want to draw the square along with me, that may help you make all these connections from protons, electrons, neutrons, all the way to the Bohr model. So remember, we've got 6 here for carbon. It's C, and its atomic number, excuse me, its atomic mass is 12.011. Remember, as a little review here, that this number here we call the atomic number. This number here we call the atomic mass or weight. And now let's calculate protons, neutrons, and electrons of this carbon atom. Remember, it spells pen. Protons are positive, electrons are negative, neutrons are neutral. So there are 6 protons. How do we know that? Because this number right here, the atomic number. Electrons equals 6 as well. And recall that protons have a positive charge, electrons have a negative charge. So the positive and the negative balance out. Sometimes neutrons is the same number, or sometimes it's different. And this one, we take this number right here, 12.011, and we round it. So we get 12, and then we subtract 6 from that. So we take the atomic mass, which is this, subtract the atomic number, and we get 6 neutrons. And these have no charge. So that's what we should know when it comes to calculating protons, neutrons, and electrons from the atomic mass and the atomic number. Now we're going to take that information and we're going to draw an image of the Bohr model of this atom. And in order to start how to draw a Bohr model, you start by drawing a nucleus. So this thing right here, this first thing is the nucleus. You can picture it as a solid central core. So this is not a ring. One of the first, if we mess this up a little bit when we first learn how to do this, we draw our electrons around this. This thing you can think of as a tiny central core here. Okay. And inside of it, I'm going to zoom in here. Inside of it, you have protons and neutrons. So inside here, we write 12 protons. Just put a positive sign. No, I'm sorry, not 12. What am I talking about? Redo. 6 protons, because it's carbon, and 6 neutrons. That's what's in the nucleus. We zoom back out, and now we have to put electrons in rings around the nucleus. So this first ring you draw about right here. And we're going to draw 2 rings around this. Now, how do we know it's 2 rings? Well, remember, once again, we can use our periodic table as a clue. Since carbon is in the second row, or the second period, that means it has 2 rings. So second row, 2 rings. The first ring can hold, and you don't need to draw this, just want to show you this, can hold 2 electrons, and the second ring can hold 8 electrons. So we could hold a total number of 10 electrons in this drawing. We don't need 10 electrons though, do we? Because if we look here, electrons, we have 6 electrons needed. So here's how you populate it. Just like a clock, you can picture a clock here. If you look at $12, $3, $6, and $9. So you go clockwise when you're populating this. When you draw these on there, we start with at the 12 o'clock spot. Now the first ring only holds 2, so we don't have 4 spots, do we? So you just go top, there's 1 electron, there's a second electron. So there's 2 electrons so far, top and bottom. The first shell can only hold 2, right? Second shell, now we start at 12 up here. There's 3, 4, 5, and 6. So we have the first electron, the second electron are on that first shell. Let me show you that here. I'm going to zoom in on this. This would be the first electron, the second electron, third, fourth, fifth, and sixth electron. So that's the Bohr model of carbon atom. Right there. There it is. Easy enough. So that's an atom with 2 rings, and it has 2 in the first ring and 4 in the second ring. Let's go ahead and do another one. Let's do sodium as our next example. Sodium is atomic number 11. It's Na. Its mass is 22.990. So now go ahead and calculate the number of protons, electrons, and neutrons for sodium. We got 12 neutrons because we took 23, which is the number that 22.990 would round to. Take 23 minus 11, or the atomic mass minus the atomic number, gives you the number of neutrons. So our Bohr model is going to have 11 protons, 11 electrons, and 12 neutrons. We go ahead and draw the nucleus first, remember? There's that. If you want to color this just to kind of show you that that's solid, that's the idea there, okay? That's not a ring, that's actually a solid nucleus. And remember, in the nucleus, there are protons and neutrons. There's 11 protons and 12 neutrons. So that's the first step of the Bohr model, is to draw the nucleus and put the right number of protons and neutrons from the thing you just calculated over on the left there. Now you put in the rings. Okay, look at your periodic table first. What row is sodium in? 3. So it's in the 3rd period, so we know we have 3 rings on that one. One, 2, 3. Now you have to put in the electrons. So if you look here, there are 11 electrons to put around here. 2 in the first ring, 8 in the second ring, and then whatever else you need in that 3rd ring. So 1, 2. There's a little trick when you pair them up. Let me show you. So there's 1, 2, 3, 4, 5, 6. That was carbons, wasn't it? Pair this one up next to it. 7, 8, 9, 10. There's 10 electrons. Start up there. There's the 11th electron right there. So sodium has 11 electrons around it, and I'll show you the order that we did that in. You don't need to write down the numbers on the electrons. I just want to show you so it doesn't just look like random stuff. 1, 2 in the first shell, 3, 4, 5, 6. Those are 6 electrons there. Then we started partnering them up. 7th, 8th, 9th, 10th, the 11th electron goes there. And if you had to for homework, draw your 12th electron, 13th electron, 14th electron. Think about where those would go. All right. So there's the Bohr model for sodium. If we go back here, just kind of review, atomic number right there. Atomic number tells you the number of protons. All right, the number of protons is always the same as electrons for an atom. We figured out the number of neutrons by subtracting this number here, which rounds to 23. Subtract that, the atomic number, to get 12 neutrons. There you go, that's how that worked. Then we took this Bohr model and we drew the nucleus, which has 11 protons and 12 neutrons. And then we drew the shells around it. We know it's in the third row on the periodic table, so we'll draw 3 shells. Now, the only one that don't follow those rules are potassium and calcium. If you look at them, they're in the 4th period, but we can draw those electrons in the 3rd shell with this activity. Okay.